Hey everyone, welcome to this Azure 801 course, Configuring Windows Server Hybrid Advanced Services. My name is Peter Detender, and I'm a Microsoft Technical Trainer here at Microsoft. This course has a total of 9 different modules, where this next module, it's all about implementing Windows Server High Availability. So we got 4 different sections, 4 main topics that I want to cover. Obviously, first of all, explaining what does it mean to deploy a Windows Server-based failover cluster, like creating a high available, reliable environment. That's mainly the message. Next to that, we're going to continue, but then talking about how to build it on top of the Azure platform. Now, depending a bit where you stepped in this course, if this is the first module, again, first of all, thanks for joining. If this is the next module you're watching out of this course, you already know that we typically have one module covering the on-prem server-specific operating system aspect, and then the second module is typically covering the same domain, but looking at it from an Azure perspective. Now, the high availability module is just about server high availability. The cool thing is that there's no difference building high available clusters in an on-prem hybrid environment or in Azure. So that's why there's only one focused module. Now, moving on there, we're also going to talk about deploying scale and high availability, because there's a fine difference between deploying multiple servers, that's what clustering is for that high availability, but it could also help you in optimizing scaling, like adding or removing servers when it's needed. And then the last topic is going to focus on high availability for one specific workload, where we pick the server file options. So with that, I would say you know what we're going to cover in the next 30-45 minutes. So I would say let's jump in. So what does it mean here in the first, implementing Windows Server Failover Clustering? It's the first section. It's all about what is the core of deploying a failover cluster, where we're going to start with what is failover cluster, pretty easy. And then next to that, looping through the definition, the setup, the planning about it, thinking about what do we need, what is the business requirement, eventually going through the setup, and then obviously also managing the actual server, and then running a failover, running a failback, because that's what we typically do in a real world environment. And then again, touching on some storage specific aspects of your failover cluster integration. Now, when you think about failover clustering, I mean, the basics of this is I want to run a high available workload. Anything that runs, or almost anything that runs on a Windows Server platform, could be a good candidate for failover clustering. You get a few options here on the left-hand side, file shares. You deploy one file server. If it's no longer running, users cannot connect to the files, and that means it's probably business critical enough to deploy more of them. It's not about 2, it's not about 5, it's not about maybe 50 or more. The concept is we're going to deploy more than one. That's the main idea. But you could also deploy virtual machines. What this means is you're going to build your Windows Server Hyper-V platform using them as the hypervisor host and deploying virtual machines on top of that, where now that underlying host model will act as a failover cluster. You could use it for databases. I'm mainly thinking about SQL Server, but you could deploy Oracle databases and maybe some other ones that I no longer use because I'm specifically in that Microsoft Trainer world now. And then overall messaging like Exchange Server, if it's still running on-prem in your environment, I can imagine that email is again pretty business critical, and that's where you could also move it into a failover cluster. A bit on the architect topology side, that's referring to the diagram here. So what do you need? You need a server, but again, preferably 2 or more of them, right? Next to that, you need what we call cluster storage. You can see here it's shared services. Typically I2C like a fiber connection, maybe I2C over the Ethernet in your on-prem environment. And then also, obviously, you need a network and you need clients. Clients and users connecting to the workload. That's mainly what it means. If it's becoming a little bit too complex, like there's security in place, there's management in place, what about my Active Directory integration? Well, that's exactly what my next slide is going to cover. You have different failover clusters. So in short, what is that cluster? you deploy Windows Server, again, 2 or more, and you need to install that failover cluster service role. Now you have domain joined and workgroup-based scenarios. In the end, I would say for the actual failover concept, it doesn't really matter. I don't know how many of you are running non-domain joined servers, but maybe like a parameter DMZ-alike network, could be workgroup-based. Maybe it's a little test environment for a specific workload. So I like to assume that all server capacity is running Active Directory domain-based, but maybe it's not the case in your scenario. And that's what we wanted to highlight here. Now from there, you're going to define your actual setup. So we talk about failover clustering. Again, you install that failover cluster service on each and every server in that server group. That's what the cluster is about. And then you also need to think about what we call the clustering quorum and the clustering witness. Now, what is the clustering quorum? So the quorum represents the number of clustering components. So it's to allow you to have that majority in case something goes wrong. Like imagine you got 2 servers. If one of them goes wrong, like it's no longer online, it's not running anymore, then the other server will take over. But what happens if you got 3 of them? How can each and every server know, like, hey, am I the winner in the cluster? Am I the only one left in the cluster? So that's really what that quorum is going to do. And next to that, you have that witness. So what is the witness? It's where you're going to add that quorum that I just talked about into any of the 3 topologies or components. Traditionally, I would say on-prem, you're probably going to use what we call a disk witness. This is a cluster disk like you saw in the previous diagram. You got 2 servers, you got shared storage in between, and you're going to use that shared storage as the 3rd component in the cluster to identify the majority. You could also use a file share. If you're not using cluster disks, if you don't want to use them, or you just make it a little bit easier in the config, you can use an SMB file share. And then leaning a little bit into hybrid cloud, you can now also use an Azure Blob Storage, like an Azure Storage account, as that cloud witness. Not just for Azure running clusters, but also in a hybrid model, assuming that your network topology obviously allows that communication. Now, I've been managing, running, deploying, migrating pretty much anything I could do with Windows servers in the physical world long time ago when I started my career, summer 96. But then obviously following all different waves from NT4 server, Windows 2000, 2003, 8, 12, 16, 19. And that's where I shifted more and more into the Azure world and not always touching on servers every single time of the day. In any of those almost 30 years in my career, I gotta say that building failover clustering is complex. We don't have the time to go through all the details, what it takes. Yes, I do have a few demos coming up here and there to show you some of the aspects, but it takes a while to architect, it takes a while to really build it. And that's mainly what we wanted to highlight here. It's not just like, I'm gonna jump in and I'm gonna deploy it. That's the main message. Why not? Because high availability means something different for any kind of organization, and maybe even different for any kind of workload that you want to manage. High availability could mean anything from it can be down for maybe a couple of hours to it needs to be 100% high available, like no downtime allowed. That's the importance of planning, thinking about what you're going to do. A little bit more technical, you're going to think about which workloads do I need to integrate in a failover cluster. Maybe there's some migration needed from a single standalone into that failover cluster. So it's not just the setup, but also the migration piece. You need to think about capacity. You need to think about resilience. Like, again, what is my SLA? What is my RPO, RTO, like recovery time objective, recovery point objective? But you might think, like, isn't that a little bit closer to disaster recovery? Why, yes, it is. But you also need to bring that into the story. Like, do we actually need high availability? Do we need disaster recovery? Because it's 2 different things. The good news is, apart from this module, we actually have another module that specifically talks about disaster recovery for Windows servers, on-prem, hybrid, and specifically in Azure. So if you're floating a little bit between, do we need high availability? Do we need disaster recovery? make sure that you're going to go through that module as well. Next to that, you need specific hardware/virtual machine requirements, quite some network traffic, allowing blocking specific network ports, and then overall, obviously, the software requirement where there are a few dependencies. After the planning phase, you're going to start thinking about, we want to make this happen. We're going to run this. So although I told you it's quite complex, I got to say over the different versions of Windows Server, it actually became a lot easier. Maybe even better if you use automation like something PowerShell-alike, right? You could probably automate a lot of this. It starts with validating the cluster. So this is validate the current infrastructure that I have. What are the requirements? Is it the correct operating system? Can I mix environments? And so on and so on. Next to that, you're going to move into the actual deployment. Create a failover cluster. Using Failover Cluster Manager, it's like a dedicated little management console in the operating system. Or you're going to use that Windows Admin Center that we talk about in an Azure 800 training. And I used it in a few of my previous module demos as well. And then as part of the configuration, you're going to integrate the quorum, where again, you need to think about any of the three topologies. So now we got the baseline ready to actually manage our cluster. So what does it mean? We need to add nodes into the cluster. You might have a scenario where you need to pause them because of like maintenance. Maybe you're moving servers around. Maybe you have planned downtime for that node. Maybe you need to run software upgrades, anything like that. And then obviously you could also evict a node, which means we no longer need it. We're going to remove it from the cluster. Once you have your cluster up and running, one of your go-to scenarios for knowing what's going on is looking at Event Viewer, just like anything else in the platform. And just as an FYI, we do have a specific topic, like a module on monitoring and troubleshooting with Event Viewer. So not going to detail too much, just going to highlight how it reflects failover clustering in that Event Viewer. And then last, talking a bit about cluster-aware updates, or the CAU, as we typically called it as Windows admins. What it means is that you're going to allow the cluster to update itself without any dramatic downtime, or maybe no downtime at all. That's what a little bit my next demo is going to show you. Now for this demo, I'm going to walk you through an already existing setup failover cluster where it's using SQL Server 2019 as an example, but in the end it's having two nodes, shared storage, shared services, where we're using the database, obviously in this case, but it should give you quite some idea about what it takes to actually configure, manage clusters. And then I'll also show you how you can bring nodes in the cluster up, how you can bring them down, and then maybe even evicting from the cluster. If you want to get through all the step-by-step instructions, remember at the start of the course, I pointed you to our AZ-801 course link, open source on GitHub, where we do have a lab about how to implement failover clustering, not using SQL, but using traditional clustering. But I'll walk you through as many steps here as I can show you. So my environment is two nodes. So what we have here is a shared cluster service. It's called Trainer SQL Cluster. And as you can see, my cluster is online as it should be. I'm using two nodes and a domain controller, where the domain controller is configured as my quorum and majority server. And that's where you can see I didn't use Cloud Witness. The interesting piece here is that it's showing up as failed. And it's also what you can see up here, that it's flagged as, oh, there might be something wrong. Now, technically, there's nothing wrong with the cluster. It's just that I'm not using the Cloud Witness. So it's more like an option instead of a necessity. If I drill down on the roles, you can see here that I do have my cluster and it's currently showing up, but it's just because I didn't start it long enough yet. And what I can do is, for example, adding more cluster roles into it. So I would click next, and then just as an informational, showing you what it takes to actually deploy more clustering scenarios. You have obviously the built-in Microsoft scenarios like a file server, DHCP server, but it doesn't need to be Microsoft. So you could have clustered web servers or generic applications using it as a target server, where later in the presentation I'll talk about scale-out file server, messaging services, and maybe some other options. So from here, let's say it's a file server. That's where it's going to ask us like, hey, what kind of scenario do you want to offer? Traditional file server or the scale-out file server that we talked about. And it's going to ask for a name. So this could be the MTT storage. And this would be the name that we provide to our cluster service. So that's also important. The node servers are not really using their name for any of the services. It's all going to point to the cluster name. And then obviously from here you would add storage, but since it's a database server, I don't have any specific storage, but that's basically completing the setup of the node itself. So let's move to the next topic, where we have two nodes. And you can see here they're up. They've been running for like a couple of minutes. You can see memory, CPU, and all the other baseline scenarios. Each server is connected to the network, one for the network, one for the monitoring, as it should be in a real-world scenario. Validating the roles where we already talked about them. And again, I don't have disks, so nothing to show here. If your cluster is up and running, which by the way, I can show you by switching to my SQL. If you're wondering how you connect, as I mentioned, we're connecting to the SQL cluster server. We're not connecting to individual nodes here, because obviously that's a big part of what the cluster is for, to not have to worry about which of the servers would be or would not be online. So if you're familiar with traditional SQL Server, connecting to it with the cluster setup would be the exact same thing. Let's move back to our cluster. And from here, we can, for example, run a pausing scenario where we're going to drain the roles, which means I don't want this server to be in the cluster anymore. And then obviously, a little bit later on, we're going to bring it back. So that's where in the presentation, we talked about failover failback. If I don't need my machine anymore, I might actually be able to bring that in. Other actions is stopping the cluster and then eventually evicting from the setup. So I would say let's give it a try. I'm going to pause my server. And this means that everything on the server will still be there. It stops responding, and eventually it's going to highlight that there is a problem with my cluster. So now it's paused, but my server 1 is still up, and that means there's no real impact, no downtime. And then from there, you would or resume, like fail the roles back, because now the cluster, all the services, the databases, the clients, the apps are all connecting to SQL Server 1. And then from there, let's say we have a more serious problem. You would stop the cluster service. So now the server is completely down. From a cluster perspective, it's still running. That's not the problem. And then evicting it means that, oh, Peter, watch out. Do you really want to stop using this machine as a cluster? And that's where we could confirm, and then it's going to nicely remove it, but that's going to take a little bit of time. Other information that we have here is specific cluster events, where you can see here now, obviously, because my nodes are getting evicted, it's going to tell you like, whoops, there's a lot of stuff going wrong. And it's not different from the traditional event viewer. It's just because you're on the cluster that you have that filtered option. But we talk more about event viewer in one of the other modules here in the course. So I guess with that, it's a quick, easy demo how to use Failover Cluster Manager to validate the cluster, to check if the nodes are up and running, and then going through the failback and failover process. So that's, I would say, the first part where we touched on the Windows Server baseline, Windows Server topology, using that high availability aspect with clustering. But you could also have a slightly different approach to creating a high available environment, And that's what this little section is about. It's storage replica. So what is storage replica? The idea is that you're going to build high available clusters, everything we talked about before with just Windows Server, but now specifically targeting a storage server. Could be a file server, could be that underlying storage environment for maybe your Hyper-V, virtual machines, or the traditional SMB file shares would also work. If you take a look at the diagram here, it's going to show you a couple of different servers, like left side, right side, maybe even two different buildings, depending a bit how far you want to stretch your clusters, as we call it. And each and every of those little circles reflects a storage pool. So you have your physical/virtual machine, you define it as a cluster, but then underneath you have your storage environment, which could be a file server system like a Windows server acting as a storage environment. And then obviously, if you want, you could also integrate like actual physical or in meantime also virtual storage network appliances. To achieve the same thing, making sure that whatever is stored in that storage environment is high available. That's mainly what we want to get out of it. Now you heard the term stretching clusters. So what this means, if you think back a little bit about the previous diagram, a stretch cluster typically means that it's going to run across different data centers. When you start deploying high available clusters across different data centers, it means that there's more distance between them. You also need to take a few things into account around latency. There's a few numbers here like server versions, 2016, but that's because it's supported. 19, obviously the latest. 2025 also still allows you to build it out. And that's what I had in my demo environment. Then the 1G Ethernet adapter, I think that's probably a default for your data center. You might have like a 10G, maybe even more than 10G capacity. But again, keep in mind that the further out you're going to stretch your cluster, it's going to impact some latency, which might generate some weird event messages, or even breaking the cluster or not giving you the full high availability that you were looking for. Everything else I would say is nice to know, but I'm not going to read all the bullet points. So if you want to spend some time on this, know that we also have our Learn platform with all the content, or otherwise just click the pause button on the video, and then you can read through each and every of these items in your own time. Cool. Now we talked about clustering, where at the start of the section, we positioned typical high available workloads, messaging servers, file servers, and we also talked about virtual machine servers. It's not the virtual machine, it's the underlying Hyper-V layer. So we're going to zoom in a little bit more. What does it mean to deploy that Hyper-V server? Where I got to say, we're not touching too much on the Hyper-V setup aspect itself. The assumption is that you already know what it means, what it allows you to do, building your VMware-alike scenario if you want. And that's also what we cover in an Azure 800 course. So if you're new to Hyper-V, maybe you're migrating from VMware or thinking about it, then I would say this section is not going to give you all information that you need. So there's a few assumptions, so just wanted to be clear on that. Now what this section is going to cover is using the high availability concept of that clustering that we talked about in the previous section, but now specifically for Hyper-V hosts. What about network load balancing? What about network configuration? And then helping you understanding if I have my Hyper-V hosts, like simplifying two different hosts with a whole bunch of virtual machines, how can we move virtual machines around in that cluster? I don't always want to map it with VMware capabilities, but like the vMotion, allowing you to pick up a VM that's running here, moving it into another Hyper-V host. That's what we call Hyper-V Live migration. And I'm going to show you and talk about it, obviously. And then last, closing with some Hyper-V storage migration as well. So again, quite some topics to cover. So I'm going to jump right in. What are high availability options in Hyper-V? So again, Hyper-V means you have this baseline hypervisor, typically physical servers, where on top you're going to deploy virtual machines. So now when you think about high availability, you actually got a few different options. The first one is making your baseline, your foundation, high available using clustered services. Your Hyper-V host becoming a cluster, and it provides that high available platform. Another option is implementing clustering inside the virtual machine. So now it's not just the baseline, it's each and every VM running inside the Hyper-V host environment is using clustering. And then the last option, it's not 100% clustering based, actually not at all, and that's just network load balancing. One, I would say, real world use case for network load balancing is where you have like a web server, typically a stateless architecture. You got web server 1, you got web server 2. The data inside like the web application might be deployed using some automation scripts, maybe using like a FTP uploads or something similar, maybe some DevOps pipeline automation, where now it means that we don't need that high-end complexity of the cluster, but I still want to allow those servers to communicate with each other and also detecting if one server is down that the other one takes over. That's like the baseline what network load balancing or NLB is giving you on a virtual machine operating system level. The cool thing is that you can actually combine all three of these in one single setup, which means that you could have a Hyper-V server, high available clusters, the baseline, the foundation, and then the workloads within are also clustered. So it's like double clustering inception. I don't really know how to describe it. I'll start with the easy one. It's Hyper-V NLB network load balancing. So again, NLB is that load balancing out of the operating system. It's the most easy way to deploy network load balancing. I remember years ago, even before like the physical load balancer appliances, I already deployed this in like a server, I think 2008, maybe 2003, but that's way too long ago, where we already had NLB as a capability. You deployed 2 Windows servers, you configure the network card, literally physical or virtual, a couple of years after, and it's creating like a shared network interface. From there, it's continuously checking, hey, server 1, are you there? Server 2, are you there? And if not, it would redirect traffic from one server to the other. So pretty easy, pretty basic, but again, super simple to set up. But some customers didn't always trust it, but it's there, so we need to talk about it, right? Other touching point here is that live migration. So what's the setup? As I mentioned before, you have 2 Hyper-V servers, 2 or more to be correct, but in our diagram here, we got 2 of them. Node 1 in the cluster, node 2 in the cluster. By the way, it's important, you need to have that clustering concept here. And what we're doing is literally moving virtual machine configuration from one Hyper-V server to another. We're not moving the virtual machine disks. That's where the cluster storage comes in, because in this even basic diagram, our 2 servers have that clustered shared storage. That's where the virtual disks are running. Literally important, running. Live migration means we're going to move the virtual machine that's running on the left server, moving to the right server, and there's almost no downtime. Maybe like a couple of seconds, but typically, depending a bit on the workload, I have to be honest, but typically there's no downtime for the application within. Managing it, you can imagine a lot of different options, triggering it in a manual way, triggering it with PowerShell, using that Windows Admin Center. I think it's just so cool that I'm going to show you how to do all this. So for this next demo, I'm going to show you some of the key parameters you have to go through to make Hyper-V live migration possible. Now we're still in my demo environment, and the starting point for making live migration possible is defining delegation. So what it means is that we start on our domain controller, and inside Active Directory users and computers, you go to your Hyper-V servers. So I have node 2, node 3, and then inside the properties of each and every node, you go to the delegation tab over here, and that's where you find a couple of different options. Now in my setup here, just to make it a little bit easier, but also showing you that there's a lot more options, I defined trust this computer for delegation. So this is that constraint delegation that I talked about as part of the presentation earlier. Now, in real-world scenarios, you would probably identify not all services. So what you need in a live migration setup would be the CIFS, because it's interacting with the file system. And a little bit further down in that list, you're going to see the Microsoft Virtual System Migration. So those are the two prime services you would need. But constrained delegation allows you to build up that trust between the two servers, in this case, trusting each other to trigger tasks. That's mainly what we're doing here. Now, there's a lot more options where you could use it for like SQL Server interaction, using it as a storage replicator, which I'll talk about later on. So just know that the options are there. Obviously, you define the same in the other direction. So after the constraint delegation has been configured on our Active Directory level, we can move over to the Hyper-V node, where I'm running two Hyper-V servers, node 2 and 3, and within I'm running a few virtual machines as a demo setup. Live migration from here starts with triggering the move operation, and you can do that from right-click, select move, or you can select it from here as well. It's starting a little wizard, and depending on your scenario, you're going to use a couple of different options than maybe the ones I'm showing, but it's just to show you how easy live migration can actually be triggered. So you can move the virtual machine and then optionally storage, or you can move the storage. So really, depending on your scenario, you would use one or the other. You define the target server, where in my case, my target is number 3, because it's currently running on node 2. And again, it's asking, what do you want to do with the virtual machine? Do you want to move the virtual machine data to a single location, which could be outside of the cluster, move the virtual machine data, or just move the virtual machine, where in this case, you need to have shared storage? And that's what I'll talk about right after this demo when we touch on cluster shared volumes. So in this case, I'm going to go for the single location, where it's going to ask me like, hey, where do you want to move them into? So this could be a migration like from one host to another. And let's do our temporary storage. Let's do virtual machines. Obviously, in a real scenario, this would be a lot better. And then basically configure next. You click finish, and the process kicks off. So that's pretty much all I wanted to show you from here. Let's go back to the presentation. Good. Now, what we did in our previous section is talking about Hyper-V live migration. One component in the whole topology, apart from Hyper-V, the virtual machines, is that storage component. So another option apart from the live migration, where you're moving the virtual machine config but not the underlying disks, is now also actually moving the disks. And that's what we call Hyper-V virtual machine storage migration. Now, the migration part typically gives you the idea like, I need to move or I need to use this when I'm moving workloads from one server to the other. Now, technically, you could also use this in like a stretched environment. So imagine that, again, our simplified diagram here, we got two servers, server 1, server 2. We have a client connecting to Hyper-V, managing, hosting it, and we have a set of virtual machines. We pick up the VHD file, we're going to move it around, and we drop it into another storage backend. That could be an option. The second one is if we want to split up, like stretching our environment, then maybe you also need to integrate your storage migration. We're not done yet. I don't have a demo on this, by the way, but we're not done yet with our building high available environments, but now we're leaning a little bit to the Azure world. Remember, this is the one and only module where we try to bring the same topic in one single module. All other modules is on-prem traditional Windows Server setup, no matter where the server is running. And then the second module is focusing on same topic, same topology, but now touching it from an Azure perspective. Now, this module is not really doing it. Why? Because you already know you can deploy high available clusters. You can interact with Hyper-V, no matter where the servers are running. So this next topic is, okay, we talked about clustering, assuming on-prem, maybe a little bit hybrid, but not in Azure yet. Well, now this next section is how can I deploy high available and scalable servers, virtual machines in my Azure environment. Important here is two different scenarios we want to highlight. How to deploy virtual machine scale sets, like really building out a cluster, a group of different servers, where you're going to benefit from the scale of cloud, which means that you can define which servers are running, what kind of virtual machine sizes am I using, am I adding more servers, or am I moving from small machines into bigger ones and then resizing back to small whenever we don't need that compute capacity. Second aspect is integrating load balancing in an Azure perspective where NLB, the network load balancing, as you'll find out, is not supported. And that's where we need to look into another Azure-enabled load balancing mechanism. And then the other topic, it's a little teaser for another module, I have to say. It's what about disaster recovery? Because remember, there's a fine line between high availability, aiming or architecting for no downtime, or allowing a bit of downtime. And that's where Azure has a pretty perfect solution already baked in the platform as well. So I would say with that, let's jump in for another series of slides, and in between a couple of demos coming back as well. So the first option is a virtual machine scale set. So in short, what is a virtual machine? It's again Hyper-V in an Azure twist, and you're going to deploy it. Now you can deploy, easy said, as many virtual machines as you want. But that's not exactly the same as a scale set. So why not? Because a scale set is that collection, a group, they all know about each other, if you want, all running the same kind of workload. Next to that, you can enable scale set options in the Azure platform, allowing you to define how the cloud platform is managing, like adding, increasing, or decreasing the amount of servers. Easy said, whenever there's more demand coming in, like I got more users, which means I need more compute power, scale sets allow you to add more servers into it. But it also allows you to not only add more servers and remove them as needed, but also moving from a small VM into a bigger one, and then again, moving back. That's what we call horizontal scaling or vertical scaling. So what is the vertical scaling? It's what we call scale up, scale down. It means that you have a certain virtual machine size and you're going to move to a bigger VM, more CPU, more memory, and when you don't need it anymore, you're going to bring it down again. Moving from a small to a bigger one is probably increasing the cost, and that's where you might play with those settings a little bit. Horizontal scaling is, I would say, what I personally prefer a bit more, because resizing the VMs in Azure also comes with downtime. It's just a little bit, typically like 10 seconds to a minute, but that might impact your high availability. Horizontal scaling is where you're going to allow the group of servers, initially you start with probably 2, and you allow the platform to look into the settings like CPU or memory consumption or disk read write or network traffic. A lot of different options that I'll show you in a demo, where you're going to allow the platform, manual, you're in control, or automated using auto scaling, where it's going to add more servers when needed and automatically remove them when needed as well. Little screenshot here, but you can already imagine that it's a lot way cooler to just show you what it looks like. But I would like to emphasize the auto scaling option for a second. What it means is you're going to define scaling rules. And as you can see in this simplified example, we force our scale set to use at least minimum 2 servers, maximum 2 servers, and then the default would be 2 servers. Now this looks a little bit weird to me, because what we do here is defining like, hey, you have at least 2 servers, but you can have no more than 2 servers. So that basically means there's no real scaling. I think it's just to emphasize that you need to know what you're doing. It's not really wrong in the setup, because this would run perfectly fine, but it's driving your attention to know what you're doing. I had scenarios at customers where they go like, ooh, maximum 500. But what about your application? I had scenarios at the customer where clusters were using a lot of CPU, a lot of memory, but not all the time. Like let's say if it's a HR application at the end of the month, like transforming your payslips, sorry, vacation days, maybe looking at your timesheets and everything else, maybe sending it off to invoicing of your consulting time to customers. If at that moment in time you configure scaling, you're going to like, I need a lot of compute power, so I need a lot of servers. But then throughout the month, maybe that workload is not doing a lot. Even worse, if you enable the parameters in the wrong way, like again, adding a lot of potential maximum capacity, what about memory leaks? What about CPU leaks in your applications? It means that maybe your auto-scaling option is not seeing that there's no CPU load. It just looks like there's continuously load on the CPU and it's just adding servers, but it's never removing them. So that's where I would say be a bit careful in defining minimum, maximum. Minimum is probably okay because it means not a lot of servers, which means you can control the cost. But then the maximum part is sometimes a little bit more tricky. Bottom line message, don't look just at the VM, but also look at what's running underneath. Then when you deploy your high available setup, when you deploy scale sets, a little bit based on that clustering, but it's not 100% clustering anymore, it also means that you need a load balancer. Why? Because if you, like in this example, you deploy multiple web servers. There's 3 of them, but this could be 300 of them, right? Next to that, we have the business tier, like maybe a database, like a SQL Server or any other tier. And that means that now we recommend an architecture having a public-facing load balancer, like that's where the internet incoming traffic to the web servers comes in, and then an internal load balancer to spread the load and redirect the load across different SQL backend servers. That load balancing is crucial for the scale set. Because if you deploy multiple VMs like web servers, but they don't know about each other, and you don't have that load balancing on top, then obviously the topology will never really know, like, hey, VM1, are you still there? Do I need to send traffic to VM2? And so on. And keep in mind that NLB is not supported on an Azure virtual machine. Again, talked quite a lot, but it's just because the setup is so important and so crucial for you to understand. But you can imagine that Peter not only likes to talk about it, but also showing you how all this can be set up. So I'm going to show you a bit how easy it can be to deploy an Azure virtual machine scale set, including the load balancer, defining some of the minimum maximum settings, configuring the rule base, and then seeing the scaling in action. So let me quickly position what an Azure scale set looks like, starting from the load balancer options and then zooming in on some of the scale set characteristics. Now, out of my demo environment, I'm using a Kubernetes cluster as an example because I think it's one of the nicest scenarios to showcase where the benefit of scale sets are actually coming in. But obviously, it doesn't need to be a Kubernetes cluster. If you look at my resource group, I have a lot of traditional Azure resources. I have my public IP, which is linked to my load balancer. I have another public IP address, again linked to the load balancer, but not in use yet. I have a traditional Azure VNet and subnets, and then obviously most relevant is the scale set up here. When we look at the load balancer and think back a bit about the diagram that I showed you in the presentation with the front-end load balancer and the back-end, I don't have this in this setup. This is just a front-end where it means that we do have our load balancer with the front-end IP. And right now I allocated 2 of them. But again, as I mentioned, only one of them is in use, but obviously you don't really see that. The backend pool is where we're now communicating from the load balancer into our backend scale set. And this is again pointing to my Kubernetes cluster. Another big important aspect of a load balancer is obviously knowing if it runs healthy or not. So that's where you define a health probe. And since this is created using a script, the naming looks maybe a little bit confusing. But what we're going to do here is defining a random port, TCP port 30,000 something, and checking every 5 seconds. That's mainly it. Where the actual port that we're going to use is port 80. It's because inside my Kubernetes cluster, I'm running a web application. But the health check cannot run on the same port than the service itself. Next important piece is the load balancing. And this is, as you can see here, we have a route, you could say, or the actual load balancing intelligence, where we're going to look into IPv4, TCP, and check port 80. And then once more, use this health probe to validate if that service is working fine, as it should be. We're almost there with the configuration. So we got inbound rules, we have outbound rules, and that means communication from the load balancer to the network using network address translation. So I hope that sort of makes sense. But in short, what we're doing is capturing information from the public internet. Traffic is sent through the load balancer. And if it's a request on port 80, we actually have our workloads up and running, which in this case are containers. From here, let's move to the scale set concept and walking you through some of the details. So the first part, it almost looks like just managing a single VM. Why? Because we have all characteristics. We have the size, but in this case, we got 2 running instances. The public IP address, which is obviously the one pointing at the load balancer, traditional VNet and subnet for my cluster, my 2 nodes. I can validate some health checks here, like the nodes are actually running. And on a lower level, I can move into the instances. I can select one of them, and it's still going to show me all traditional virtual machine characteristics. I could shut down the node. I could add more nodes into it. Now, I got to be careful with my demo here, because since I'm using Kubernetes, I have to warn you that you should not manage your Kubernetes clusters using scale sets, or not from an Azure perspective, because it should all be done using Kubernetes management integration. But a few other options that you can see here is like running upgrades, so upgrading the virtual machine, obviously deleting, re-imaging, like pretty much anything you expect from a scale set, apart from not having all machines available. And then the biggest reason and settings probably behind scale sets is the scaling itself. So what we defined here is what kind of scale do we want. Now in my demo environment, I'm using manual scale because again, my servers are typically not having a lot of load, but that's where you would probably shift to custom auto scaling, and you can define your own policies for that. So right now what it means is scale to a maximum of 2. And as I showed you in the screenshot in the presentation, you can define more scale conditions. So you could define different options, different load settings based on time zones, based on the time of day, based on the day of week. That's the scenario. And then inside availability, but that's what I'm going to talk about right after the demo, you can define your availability options within the platform. Now, by default, any scale set in Azure is also an availability set, but you could also move it into an availability zones. And that's what I'm going to talk about maybe right after closing this demo, where I think I showed you everything I need to show. Maybe last year, the sizing option, to just highlight that, again, it's just like any virtual machine, but important, all instances in the scale set do have the same virtual machine size. So with that, let's say switch back to the presentation. Now we talked quite a lot about scale sets, but you might go like, hey, Peter, I know Azure a little bit, and I also know there's availability sets. So what's the deal? Is it a scale set? Is it an availability set? And then maybe some of you are already leaning into the next slide, and that's availability zones. So in short, a scale set can actually be an availability set or a zone on its own. Now, taking a little step back, what is an availability set? When you deploy an Azure virtual machine, it lands in our Hyper-V Azure-based backend in a physical rack. The only real interaction you have to define where the virtual machine is running is the region allocation. So let's say I deploy my Azure virtual machine in East US, but then my workload becomes a bit more business critical. So logically, I'm going to deploy 2 VMs, I'm going to deploy 6 of them. As long as I deploy all of them in the same region, I'm actually creating a bottleneck. I'm creating a high availability risk. Why? Because in my mind, I could go to the business and telling them like, nothing's wrong, we got 6 virtual machines, but technically in the platform, they might, worst case, but not impossible, they might all run on the same physical rack. So to avoid that, that's where availability sets are coming in. So what in short is an availability set? Each and every physical rack in availability set terminology is what we call a fault domain. So if you deploy 2 or more virtual machines up to 1,000 technically, you can deploy 2 or more virtual machines in an availability set, and that's going to guarantee out of the platform that the SLA becomes a 99.95. It still means that it's not 100% high available, but 99.95, it's like potentially 45 minutes outage. By the way, when I talk about SLAs, it's on a monthly basis. But back to the concept, if you deploy 6 virtual machines across different fault domains, technically across different racks, it's going to make sure that, like in this simplified diagram, 2 of each of the group of 6 will always run in a different physical rack. So within the Azure platform, we could basically lose connectivity to rack 1 and 2, and then rack 3 will still host the running virtual machines. That's really what we're doing. But then that's not, I would say, considered good enough anymore, because not all organizations are happy with the 99.95, and that's where already years ago, we brought in the concept of availability zones. So what is an availability zone? It's where now we're stretching the high availability topology from 99.95 into 99.99, like the traditional, I would say, 4.9 data center SLA. It's barely a couple of minutes potential downtime per month. Out of an Azure topology perspective, it's still linked to a single region, but now it's going to look into 3 different buildings. What you see here in the diagram, like availability zone 1, think of it as a physical building, a group of physical racks, basically. So now we deploy X amount of virtual machines inside an availability zone configuration, and it means that it's going to move the virtual machines around across different buildings. You might keep some latency into account if your workload is a little bit vulnerable for that. And that's where you could look, it's not on the slide, but that's what trainers are for. It's where you could look into proximity placement group. That's going to respect the concept of an availability zone, still having multiple buildings, but it's going to keep the workloads closer to each other, meeting that high available requirements, like there's enough distance across my workloads, but they're not that far that it's going to impact the latency. That's the main thing. Proximity placement groups. Good. Next topic, implementing file server high availability. This is one of the easiest sections in the whole module. Why? Because we already talked quite a lot about high availability on the Windows Server. So we're somewhat going back to our clustering topic, where we're going to zoom in on what if your workload is a file server. Why? Probably because it's one of the easiest, but also one of the most common ones. So we're going to touch on what is the concept, what are the different options to build it out, repeating some of that storage replica concept that I already talked about before, bringing back in the cluster shared volumes, and then also talking about SOFs or scale-out file server. So again, still a few topics to cover last couple of minutes in this module, and it's all about building out that high available file server. Now, starting point here is we have, again, like always, a few different options. First one is implementing high available options using a file server. Just traditional file server, you enable files, you create the file shares, and you're going to make it available to the users using failover clustering. We talked about it all the way at the start to about halfway in this module. So if you got any questions on failover clustering, I would say stop the video, go back to the start, and just go through it again, maybe a little bit slower. Second option to build out high available file server is using that SOFS or scale out file server, where we're going to use the clustered file server type, but now it's that baseline storage foundation for workloads on top, like Hyper-V virtual machines, SQL database servers, and maybe still file servers. That would still be an option. We talk about file storage, file servers, but again, it's a little bit, or it's a file server, or it's a storage backend, like basically allowing you to build a Windows Server topology that's going to look and feel and act like it's a storage environment. One of the first concepts here is cluster shared volumes, or CSVs. Now, I know CSV, probably a lot of you are thinking about the Excel alike. That's not what we're doing here. This is, like you can see in the diagram, we have a pool of servers. Each and every server, multiple ones, they're all part of this clustering concept that we talked about, and they're all acting as a storage endpoint. 3 different servers, all part of the same storage pool, and we're going to account volumes. So a volume really reflects a physical or, yes, virtual disk inside the cluster. If you look at it from a node perspective, they're all connecting to the same backend. Like shared storage, that would be the simplification of the topology. So you're going to define that CSV scenario. 2 different types that we identify. The first one is clustered Hyper-V virtual machines. So what it means is you build your Hyper-V hosts, the hypervisor servers, counterpart for VMware, and on top of that, you need some storage because that's what your virtual machines rely on. Second option is not using it as a Hyper-V host, but using it for file shares. And that's again that scale out file server, scale out file share topology. You have different nodes in the cluster. They're all acting as file server, and you're going to share the file shares across the network. If you lose any of those nodes, there's no downtime, there's no impact because the other servers take over the load. That's the main idea. And that's a bit what this scenario talks about. I know it's pointing at some Hyper-V virtual machine VHD alike, but that's in the end, I would say, not all that important. What the topology describes here is we have X amount of servers. In this example, we got 3 of them. The 3 servers connect to what we call that shared LUN, like the logical unit, what that storage volume looks like. And then underneath, the actual file system, if you want, is using VHD files in this case. So we have 3 VHD files, could be 1 virtual machine, maybe 3 different Hyper-V virtual machines, and they're now available across the 3 different nodes. That's the main scenario. Implementation, pretty easy. I'm not going to bore you with repeating everything that I talked about. You already know it's based on failover clustering, which means that everything, again, we talked about at the start of the module is still more than 100% valid. Anything that we touched on in the planning phase, knowing what you're doing, knowing how to architect, knowing the network requirements, that's all still valid for cluster shared volumes. Nothing's changing. The only difference is you're not installing a database workload, not installing like a messaging workload, not deploying web server workloads. It's all based on just deploying storage and enabling the file server service into the platform. And then the differentiator here is with that scale out file server. So what's the idea? We still have failover clustering. We're going to deploy X amount of servers, and the X amount of servers are all acting as a storage endpoint. You're going to enable SMB file shares. That would be an option. You could use, again, your Windows servers and turning them into like a storage area network. That's what we're doing here. A big reason, and I remember, I would say the first time I think around Windows 2012, like again, quite some time ago. And for me, it's still cool that this kind of workload scenario and architecture is still available. I deployed so many different brands of physical storage, all the way from HP, NetApp, and so many other, because I worked for different partners. And then at some point it was like, but you no longer need this dedicated storage appliance from a storage vendor. You can deploy a Windows server and turn that into a scale-out file server. That was mind-blowing technology at that time, and it's so cool like 10, 12 years later that it's still available in a physical world or even in a virtual world if you want. And then back to that storage replica. So what we're doing here is again focusing on the storage backend. And as you can see here, we got 3 different scenarios: server to server, like one VM moving storage to another VM, cluster to cluster, and again that stretched cluster across multiple data centers. Important also to emphasize here is the difference between synchronous and asynchronous replication. Synchronous replication means that whatever is changing on one side of the storage replica is immediately synchronized to the other side. You can do this when there's like not a lot of distance in between. Once you have a certain amount of latency, like typically 5 milliseconds, which technically is not always that much, it means that the changes happening in one part of the storage need a little bit more time to get to the other side of your topology. And that's where that asynchronous comes in. Think back about the planning, think back about that initial setup all the way at the start of the module, where we listed up all the technical, physical, maybe requirements to also mitigate that latency. But in a stretched cluster, maybe a few different, tens of miles or kilometers in between, it could cause latency, and that might impact your topology from synchronous to asynchronous. I got another little demo before wrapping it up, and that's where I'm going to show you once more going back to my cluster, but this time focusing a little bit more on the storage aspects of my topology. Showing you, again, what the requirements are. I'm using Active Directory domain service integration, creating that resilient file system like a shared storage backend, and then showing you a little bit what that storage replication configuration looks like. So for this next demo, let me show you a bit what storage replication options are in a Hyper-V setup. Now, this is for Hyper-V, but technically it doesn't need to be Hyper-V because you can use the cluster shared volume setup for like a file server as well. So I'll start with the failover cluster manager. So I got my 2 nodes, and within I have that cluster disk 1. So that's basically my shared storage, you could say. Where then within the server file system, if I open up my file system, you can see that we do have that cluster storage over here. Next, we can enable this server for Hyper-V replication. And what that means is we need to go into the roles and we're going to install the Hyper-V Replica broker. From here, we can enable replication settings where you define the server as a replica cluster. You define which kind of scenario you want to use. If it's Active Directory joined, I would recommend you Kerberos. If you do have certificates, then obviously try to move to certificate-based authentication, where now we're going to use port 80. And then down here, you have a few more options, like allow replication from any authenticated server, or obviously you can specify specific ones as well. Now, if you don't have a cluster, or you don't want to manage it from here, you can basically do the same from within Hyper-V itself. So step 1 is going into Hyper-V settings on your Hyper-V node. You move to replication configuration, and you can do the same. Now, if I enable all this and I define replication, I configure it, it's going to tell me, oops, that's because I picked the wrong one. It's going to tell me like, hey, you cannot make these changes because your server is a cluster, which obviously makes sense. And then once all this is done, you would go into enable replication, following the wizard where you're going to define the replica server. You select the replication virtual disks, configuring the frequency, like how many times or what time stamp do you want to use to run the replication. And keep in mind over here that it also allows you to select recovery points. From there, it's going to run that initial replication. Obviously, depending on the size of the disk, it could take a little bit, but that's also where that cluster shared volume could actually help you, because then you're not really migrating any storage. That's all I had for our storage replication. Good. This was another, I think, pretty hefty module where we talked about a lot of different things, but so important: Windows Server high availability, building out business critical workloads, starting from that Windows Server operating system. So in short, we started with Windows Server Failover Clustering. What's the idea? What's the need? What's the concept? Followed by how to implement it. Then we also talked a bit about, once we start deploying new servers in Azure, what are the high availability options that we get out of the platform? No longer relying on clustering, although technically you can still deploy that in Azure, but also looking at scale sets, availability sets, and availability zones. And then last, going back to one specific workload in clustering, and that was the Windows Server file server, where we also talked about the scale-out file server scenario. With that, we're at the end of this specific module. I hope you enjoyed learning from it as much as I did presenting it, but we're not done yet. We got a few more modules to tackle in our AZ-801, so I would like to invite you to just follow me on to the next module, where we're going to talk about more Windows Server capabilities and more hybrid Azure integration. Thanks for being here, and hope to see you again in one of my other modules.